Yeah, I just started recording, and hopefully it's recorded.
Okay.
This for me, this is like second time using Microsoft Teams, so hopefully everything is recorded. Although I don't see any buttons, saying that.
I
Oh yeah,
see
okay,
that a
yeah, it says
message that
recording has
says,
started. Yeah, yeah.
Yeah, I
yeah.
think you're recording.
Okay.
Yeah.
Okay, great. Thank you very much. Well, this project is funded through the United States Department of State, and specifically through the U.S. Embassy in Serbia, and uh, Professors Validzik and Isalovic and myself applied for this funding, and we received funding to support this project over the course of 30 months, so 2.5 years. And this is our first month. We're just starting on this. Renewable energy and water for the US and Serbia. And you'll see here the project title in Serbian and the participating institutes. I won't spend a lot of time on this part of the presentation, but I just wanted to mention in the lower left here is a photograph of part of the main campus of the University of Toledo. We're located in Ohio, and I'll show you a little bit more information about the university as well. So the key participants in this project certainly are at our two institutions, the University of Toledo in Ohio in the United States. I'll just highlight some of the core participants who are going to be working on this project. Myself, I'm a professor in the Physics and Astronomy Department, and also a faculty member of the Wright Center for Photovoltaics Innovation and Commercialization. Professor Isalovic is a professor of chemistry and biochemistry here with, as you know, a lot of experience in water sustainability. Tyler Brow, you just met. He's a PhD candidate here in the Wright Center for PVIC. And Sanduni Primapilika, I'll get better at that pronunciation, is a student also in chemistry and biochemistry. And then we have Professor Ivana Validzik from the Laboratory for Radiation Chemistry and Physics, who you've met. Many of you already know. We have Nikola Ilic and Katerina Lupsic. I'm not sure if I'm saying those correctly, but postdoctoral
Perfect.
researcher and graduate student
Almost.
working with Ivana. Great. All right. So I'll try to move quickly here. So this is a project summary. I'll just go ahead and read through it because I think it's an okay way to get a good idea of what we're aiming for and what we indicated to the sponsors that we would be doing. So through mutual exchange visits, we have between the faculty and students, we have 4 visits that are planned. We will also expect to hold workshops during these visits. And we also plan to conduct joint research and development on solar cells. So the faculty and students will connect Serbia and America in support of education and communication on the importance of, and also the scientific basis of, renewable energy and water sustainability. So academic workshops on critical topics, renewable energy sources, solar energy, and energy's impact on clean water will help us to establish several, hopefully many of you as student experts who can be ambassadors through outreach in Serbia to raise awareness of solar energy's significance and to show what is possible with this technology and to make it easier to pursue these projects. These workshops will be open to all Serbian and American researchers at both institutions. Cross-institution collaboration will create a strong foundation for continued scientific and community endeavors. And the unique capabilities at both institutes will allow us to engage on topics ranging from the material science of solar cells all the way through to direct community outreach. We hope to benefit from that here in Ohio, and certainly there'll be a focus on that in Serbia. The knowledge that is developed for the students and other participants in this project, knowledge of the solar industry, all the way from manufacturing through to design, installation, and operation of solar arrays, will enable researchers and students, all of us as participants, to share, in your case, your vision with the Serbian communities to inspire new solar energy projects. So, here we are. Here's the United States between Canada and Mexico. Ohio is right about here in the Great Lakes region. And you can see a little bit of a zoom in of the kind of the Midwest region of the United States. Toledo, it's hard to read, but it's right about here near Lake Erie and not too far from Michigan. This is Ohio, Indiana, Illinois, which is home to Chicago. Detroit is our largest big city nearby. Here's the state of Ohio. Toledo's up here. Detroit's right about up here in Michigan. And the University of Toledo doesn't really show up on this map, but you can see it's highlighted here. As we move on, this shows the context for the geography relevant to Serbia and its immediate neighbors. So you can refer to these. We'll share these slides with you certainly. And here's an image of part of central Belgrade, but I won't be highlighting any locations on that map at the moment because I think Vinci Institute is not on that map quite, but hopefully we will, not quite, all right. It turns out that our climates are quite similar, both in terms of weather. So the purple lines are Belgrade, and the Toledo Express airport measurements are in green. This is showing the typical high and low temperatures for our cities throughout the year. So they're very similar in terms of temperature, and not too different in terms of clear skies, good for solar energy. It's a little bit sunnier summer in Belgrade than it is in Toledo. And Toledo maybe has a slight advantage in the late fall around this time of year, and we have a nice partly cloudy day here today. So I did not get a chance to fill out all of the details that I hoped to mention, but that'll save some time and give more time to the other professors to introduce their perspectives on this project. But I do want to point out, there are significant problems with global energy, not only now in terms of availability, highlighted because of the issues with Russia's invasion of Ukraine, but also with the implications for our environment, because as you'll see, global energy comes largely from fossil fuels still. So we need to decarbonize. We need to move away from fossil fuel energy sources and move towards electrification that can be powered by solar and wind energy, for example. I want to talk more about solar energy, more about how we can get a handle on solar energy, not only the solar resource, the sunlight that's available, but then also how much energy a typical solar array of a specific design will produce. Solar energy really is in its infancy. This technology will become increasingly important over the decades to come, and investments made in this technology in Serbia and elsewhere will pay very good dividends in terms of energy independence, the environment, and the clean energy. So again, We're aiming for clean energy ambassadors here. So I will go through these slides fairly quickly, and I will update the PDF file for sharing. These slides are typically a few years or more old, but you can see that the primary energy consumption for the world in 2016, if you look at the yellow, the orange, and the blue, those are all fossil fuels: oil, natural gas, and coal. So 85% of the primary energy was from fossil fuels in 2016. If you look at where greenhouse gas emissions are coming from, energy is 3/4 of the sources of climate change gases. So we have a real opportunity here globally to make a big change in how we generate and consume energy. Just briefly, for those of you who may not have had the opportunity to consider the scientific basis for the greenhouse effect, it's a bit different from a greenhouse in which you grow plants in cool temperatures. In the case of a greenhouse that's growing plants, you have trapped the air, and so your convective cooling with the atmosphere above is limited. So the solar energy will heat up the ground and the plants, and therefore they will heat up the air, and that air will be trapped in the greenhouse. So that's a little bit different effect than what we're talking about here, which is that by changing the mix of gases in the atmosphere, what we're doing is we're changing how much of Earth's infrared radiation that normally has escaped to outer space with a particular efficiency. We're intercepting more of that infrared radiation coming from the surface of the Earth. And once it's intercepted by greenhouse gases, some of that will be re-emitted and re-radiated back towards Earth. So it's really it's a fairly small effect when you consider it, but when you change this mix of greenhouse gases, you can tip the balance in favor of a warming Earth. And that's what we have done over the past 150 to 200 years. I will skip past this slide, but just note carbon dioxide is a really big greenhouse gas. And one of the people who started monitoring atmospheric carbon dioxide was Charles Keeling, who did this in Hawaii. And his data started in about 1957. You can see on the right-hand side here. And this is not perfectly up to date, but reaches to 2021, where we were almost at 420 parts per million at that time. And you can see here that there's an oscillatory nature of these greenhouse gas concentrations. This is in parts per million, and this oscillation is seasonal, and it's driven by the uptake of CO2 from forests, and the uptake takes place during the summer months and the release during the winter months for the northern hemisphere, because it turns out that the northern hemisphere land mass and forest coverage dominates the global CO2 uptake by plant matter, by plant growth. So that's what we're seeing here on that cycle, but you can see that the trend is upward. And when you consider this from a scientific standpoint, those are just zoomed in. When you consider this from a scientific standpoint, think about the mathematics here. You can see from looking at this curve in the lower right that we are increasing the rate at which we are adding carbon dioxide to the atmosphere. So that means that the second derivative is positive, right? So not only is it increasing, it's increasing at an accelerating rate. So our first step globally, for humanity is to at least balance things out to the point where we're adding a linear amount every year. The next step will be to tip this graph over so that it flattens out. And then lastly, we'll try to make the derivative go negative, right? Where we can start to see Earth returning to the lower carbon dioxide concentrations that existed before the Industrial Revolution in the 1800s. Certainly, let me see, look at the time. Okay, I'm going to hurry up and finish here. But you know, this is if you look at how much power is consumed in the U.S. per person, it's about 10 kilowatts per person. If you multiply that by the recent estimated global population of 7.85 billion people, you get a power requirement of 78.5 terawatts. Now that's much higher than the global power consumption, which is about 19 or 20 terawatts. It's an average power per person of about 2.4 kilowatts. And I guess the point is that we will need more energy because you know, energy is relevant for standards of living, and that is, you know, something that everyone is striving for. So my point is that we need to be able to provide that energy from clean sources. So when you think about the ways that we generate electricity primarily by burning fossil fuels or using nuclear fuels to generate heat, to run a boiler and a turbine that shows up as kinetic energy that then can be converted through the electromotive force to electricity. You know, there are a number of energy sources on here, but the one that we're talking about the most in this project is this, you know, end around where sunlight incident on a solar panel generates electricity directly. So you can see it's an elegant and simpler approach in many ways, and does not involve significant emissions of fossil fuels. I'm going to skip past this slide for the most part, but we should come back and look at this again. This shows the importance of solar energy for producing electricity and energy here on Earth. This is just a slide that shows that we are benefiting from a nuclear reactor, a fusion reactor. Of course, that is the sun that I'm talking about. And so for those of you who may not know, this acronym right here means not in my backyard, NIMBY. So we often talk about that if someone's going to build something that, you know, maybe an industrial plant that maybe isn't so clean and maybe has some pollution emissions. People might agree that it's important to build something like that at some point in time, but people would say, but don't build it in my backyard. People don't want these things close to them. So, okay, I think I'm coming to the close here. I'm going to skip past this, but this talks about the carbon intensity for our home here in Ohio. And the total power that we consume is about 2.5 kilowatts for our home. That's accounting for natural gas and for electricity. We use natural gas for heat. This is to show how substantial the growth is in photovoltaics, and it will continue to grow rapidly. This is a slide for fun. We have Halloween coming up here, so if you're looking for costume ideas, there you go. And I'll just finish with, if you can read this, I grabbed the spreadsheet information of our initial 1, 2, 3, 4, 5 presentations that are planned, and including this first one. So you'll be able to refer to this as well, either through the direct link or through these slides. I can.
Randy, those slides didn't advance.
Yes.
You know, we're still on the slide with cumulative solar photovoltaics installations.
Oh.
So like the global view slide.
Let's see. So, does anybody see the slide of the Halloween costumes? No?
No.
All right. I'm going to stop sharing. I'm going to stop sharing and then start sharing again. How about now?
Yeah, now we see them.
Oh, okay.
All
Now,
right.
now I can see.
Yeah.
Now it's making more sense. All right, I'm
And
gonna go
it's
to the next
funnier
slide,
now.
which
But I should say this is not in Toledo because I see some mountain, behind. So this might be Michigan or something.
true, probably. Do you see the slide of the presentation schedule?
Yeah, we see it now.
Okay, good. So this
So
takes us through
So it seems like
the
you're scheduled
University
to
of
give.
Toledo's. What's that?
You're scheduled to give a lecture in 2 weeks, so this will be our next meeting.
That's right. That's right. And I think that is it. This is a conclusion, some points to think about. And I will turn it over to who's going to go next.
We could go with Ivana next.
Okay, great. I'm going to stop sharing. We'll have time at the end for
Yeah,
a
we
few
will have time for
questions.
discussion. The whole idea is, that we discuss as much as possible. We don't want this to just be like formal classroom lecture.
Right, agreed.
Okay. Just for a second. I hope so that you see.
Yeah, we see your slides. Look good.
Yeah, okay.
Yes, we see.
So, okay, thank you. I'll just show you shortly something about how the university in Belgrade look like. So just short about the history. So this is the university in Belgrade. It's the public university in Serbia and is the oldest and largest modern university in Serbia. Basically, the monastery of Hilandar in Mount Athos hold this distinction of being the first Serbian university, the cornerstone of education, religion, and culture, life of Serbian people since 1198. So the Belgrade University is founded in 1808. And basically today, this university have something like 31 faculties, 12 research institutes, the university library, and 9 university centers. The faculties are generally organized into 4 groups: social science, humanity, medical science, natural science, and mathematics and technological science. So here now we go something to set shortly about the Vincha, and here you can see some really old picture when everything was started after the Second World War in 1948 on the left side, and also the scientist who founded Vincha Institute, and that's Pavle Savic. And on the right side you can see basically the picture of the institute, some new picture in today's time. So the institute is really large. We're going to see after that, I show you some of the picture. And there is employment, something like 800 people. Among them, it's around 500 researchers and professors and PhD students and also some engineers. So here you can see basically that the institute is founded in 1948 after the Second World War, and it was founded by Professor Pavle Savic, physico-chemist. And Professor Pavle Savic, basically, he worked with the 2 Nobel Prize. So that's Irena Jolie-Curie from 35 to 39 at Institute Radium, and also Peter Leonidovich Kapritz at the Institute of Physical Problem in Moscow. Here you can also see just shortly some white and black picture from the beginnings, so the really old time. And here on the right side you can see something new. Basically this one picture on the right side, it's from my lab, and this is XPS, or X-ray photoelectron spectroscopy. So as I said to you, so the Vinci Institute is today quite multidisciplinary and modern institute with more than 500 researchers. And basically the whole institute is quite large and is divided in 16 different organization units, basically, which we call department. For physics, nuclear plasma physics, theoretical physics, and condensed matter radiation chemistry and physics, atomic physics, physical chemistry, chemical dynamics, and permanent education, radioisotope, radiobiology, molecular genetics, molecular biology, radiation and environmental protection, thermal engineering and energy, engines, vehicles, and related technology, Department of Materials and basically nanomaterials, also Department of Bioinformatics and Computational Chemistry, Department of Anti-Explosion Protection and Permanent Education. So we also possess some of the centers, but it's wide. So the next slide basically also show you the Vinci. This is basically archaeological exceptional importance here in Europe. So it's on the same place as Vinci Institute. Maybe it's far away, 5 minutes with the car. And here basically found the oldest culture in the whole Europe. So from here, from the Vinci, where some of the people will visit, you're gonna visit the museum, and then you're gonna visit where really the place where the culture of the whole Europe start to grow and start to move and start to. So basically, it's founded and it sold something like 5700 BCE, and so it's collected different time from Neolithic, Copper Age, Bronze Age, Iron Age, medieval level, and so it's quite nice and unique. So now we going something just to shortly said something about the solar. This is the some information which was basically abstracted from the International Renewable Energy Agency. And here you can see basically that according to the map of Serbia, this is the Serbia solar power resource. And here you can see that the Serbia have significantly high number of solar radiation hours than the most of European countries. And the southeast part of the countries basically has the one of the best condition. Here we extracted basically how we use the solar energy around the world according to the International Renewable Energy Agency. And here you can see basically that the China is first, United States of America. And for instance, so the Germany, it's quite using more than we are using, and they are on the north compared to Serbia. And here you can see also how it looks like something of the statistic according to the renewable energy technologies, electricity generation. So Serbia compared to the United States from 2020, here you can see basically that concerning the solar photovoltaic, so Serbia, it's using really small amount compared to the United States, which is solar photovoltaic, so it's 14%. So basically, those are some next data I found concerning the Serbia. So Serbia with a population of around 7 million people, electricity production in Serbia basically relies around at least 70% on lignite coal, while most of the remainder is generator is hydropower plants. And basically, despite slow growing in the wind power in the recent years, is still made up only 2.7% of electricity generator. Here you can see basically that the hydropower and coal are the definitely dominate. And basically we can in most of the scientific paper, so we find basically if you ask why Serbia does not use the thermal conversion of solar radiation, in spite of its much greater potential compared to the countries of the Western and Central Europe? Usually the answer is the low standard of living, low electricity prices, the low level of energy efficiency in all area of energy use, lack of knowledge and political decision, and the main cause of insufficient use of renewable energy source in Serbia. But for instance, if we look the same statistic from the International Renewable Energy Agency concerning the number of patents in a solar energy, in a solar photovoltaics, then you can definitely see that Serbia have an engineer and the scientists who work in this field. So, for which probably we don't have a government on the politics. Basically, they have enough, how can I say, so feeling or the awareness of that the solar energy is quite important, and that the Serbia generally can use that in a much higher percent than they're using now. So this is just shortly something which already Randy show you. This is just I wanted to show you the timing and also some of the title of my talks. Just shortly, I'm gonna teach you basically the photovoltaics, something about the introduction. So we start from the first step. We learn something about the solar spectrum, solar source, how the sun delivers the energy, atmospheric effect, distribution of solar resource, photon flux, and everything else. Then we going in the semiconductors, and we study basically the most important part of semiconductor physics, which they are important for the solar cell. And then we are going to learn about the transport and carry concentration and semiconductor. Then we are learning about how we can make solar devices, about the PN junction, then the solar cell, and basically that will be something like the introduction, the part which we call the introduction in the photovoltaics. Then after that, this is the teaching for the first year. Here you can see basically the date. If something is changed, we're gonna inform you on time. And after that, I'm going to teach you a little bit something which I study in the last 10 years, and I'm working in science, and that's semiconductor of quantum of antimony sulfide, which I think is quite promising and important for the application in solar cell. I teach you something about the general body semiconductor, method of synthesis, devices we made, measurements we do. And after that, we are going to talk something about one other part of the photovoltaics, a part of the solar cell. We also have a quite interesting part which we call advances in photovoltaic free through light manipulation. So basically, how by using optics we can use better solar energy and reach higher efficiency of the same solar devices through better understanding of the light, the content of light, and what we can basically do. And this is something which I'm gonna teach for the first year. So this is everything from me.
Thank you, Ivana. Very nice. So I'll be shorter than my presentation is slightly shorter than Ivana's and Randy's. So I have 7 slides, so we'd like to finish in the next 7 minutes. So just to remind you, the project is based on studying renewable energy and water for US and Serbia. And as Randy has shown, Toledo is in proximity to Michigan. And if you look at this map, which comes from Google Maps, you see Toledo is to the left. And obviously this is Lake Erie. And the closest cities to Toledo are basically Detroit, which is up north, also close to the lake, and Cleveland, which is approximately 2 hours east. So it's 1 hour to Detroit, around 2 hours to Cleveland, which is here where it says Parma. So just to remind you, that the University of Toledo is a big public university. So we have more than 15,000 students, and as Randy mentioned, we have intensive research in the fields of photovoltaics, but we also have intensive research in other fields. So if you look at the campus picture here, I know it's a little bit smaller than I would expect, but you see the big tower here, and the university was established exactly 150 years ago. Okay, so it's quite old university, originated from 1872, and the Department of Physics is here approximately, and Randy's lab is on the other side of the campus, so around here. And if you look closely, you see the big the field here, which is used for some sports, I think mostly for track and field, so for running. And here's a football stadium. So besides being, good in physics and photovoltaics, we have a very strong department of chemistry. So the Department of Chemistry is found in this building here, which is labeled as Bowman Audi Laboratories and Wolf Hall. So we are a department that is highly ranked in the US and also ranked among the best world universities in chemistry. So I think we are somewhere between 600 and 700 placed in chemistry. And obviously my field of research is analytical chemistry, but as I said, I got involved in water analysis, and now I'm involved with Randy and Ivana based in this project. So you heard from Randy about issues that we are facing with climate change and with energy. I also want to point out that there are many countries in the world that are basically missing a resource of clean drinking water. So the funding that we're working on is focused on basically increasing awareness of the current status in fields of renewable energy and also water sustainability. And our major focus is on communities in Toledo and Serbia. There would be some small research component involved, more towards solar cell research. And obviously you heard that three of us represent University of Toledo and Vinci Institute. So all of you have likely heard about Lake Erie, at least many times when I was a kid, in Serbia. We had like crosswords and like doing crossword puzzles, and there was always question about Lake Erie, and it's obviously one of the Great Lakes. So if you look from Toledo side, which is to the left of this picture, and if you would drive to Buffalo, New York, which is on the other side of the lake, it takes like 5 hours driving. Obviously, this is where Niagara Falls is, and there are many nice places to see around. So what might be hard to see in this picture is that there is much of influence on the lake from the energy production. So, for example, if you would carefully look to the back of this picture, to the left, where I'm pointing with the mouse, if you can see my mouse, but anyway, toward those clouds, to the back, there is actually a tiny bit where you can see a coal power plant, and to the right, actually, there is a nuclear power plant. So those two plants are in Monroe, Michigan. So this is a small town which at some point used to have big Serbian population, like in 1800s and 1900s. But anyway, those power plants that are located on Lake Erie, they influence obviously the climate, but they also influence water temperature and microbiome found in the lake. There is also much of water discharge into lake from tributaries. So the major river coming into the Lake Erie is called Maumee River. And unfortunately, we bring many of pollutants into the lake, and the Lake Erie is also the source of water for Toledo and nearby communities, so approximately 500,000 people. So throughout this project, we're going to touch a little bit about influence of those power plants on quality of water in Lake Erie. Also, we're going to talk about sustainability during solar cell production. So there's a big company in Toledo that produces solar cells. It's called First Solar. And I got in touch with some people working for First Solar, so I got some information about their water sustainability. There are other manufacturing facilities that are related close to the lake. So there are 2 refineries in Toledo. Toledo water plant is doing a good job treating water, coming from the lake. And lake is very important for us, not only as a source of drinking water, obviously after the treatment, but also as a place for recreational activities such as fishing and for economy. And again, fishing has a big part in it as well. So I want to point out a major issue that we had in Toledo approximately 8 years ago. So in beginning of August of 2014, there was a big harmful algal bloom. And actually, that was not the only year when we had harmful algal blooms. So basically, when I moved here in 2008, I went a couple of times there in hope to swim, but actually the lake was green. And the lake is green because of overgrowth of cyanobacteria. So those cyanobacteria are called microcystis. So major species is actually microcystis. And those cyanobacteria, they produce toxins, which I mentioned earlier, called microcystins, and those are peptide toxins. So they're basically toxic peptides. And they affect liver, so they're mostly hepatotoxins, and they also could cause some other diseases, and obviously on touch, they can cause, dermatological problems. But if ingested, this water can lead to the death. Okay, and there were cases in the world, when people died. So as I mentioned, in 2014 we had the issue with microcystins actually ending up in drinking water. So Toledo water plant detected more than 1 part per billion microcystins in drinking water. So I want to point out that major cause for those harmful algal blooms are actually nutrients that come from Mami River. So I mentioned this is a major tributary to Lake Erie. And the other thing I want to point out that Serbia had issue with microcystins in Lake Erie, and actually there is a lake near Užice. It's called Lake Ruci, and the case of microcystins in Lake Ruci was basically well documented, described by a scientist working at University of Novi Sad, and basically presenting this book called Handbook of Cyanobacterial Monitoring and Cyanotoxins Analysis. So there is obviously more research and education to be done, and obviously this is one of the goals of the project, is to kind of focus on water sustainability and issues that we have in Toledo and that we also had or could have in Serbia. So I will show you a few pictures about Toledo. I mentioned to some of the people that downtown Toledo is almost like downtown Chicago. Not exactly, but you see many of those big buildings. And here's Mami River. So Mami River is approximately the size of River Sava or Danube. So in one of Ivana's pictures, you saw Danube River. So it's a really big river, and this is pictured during winter, when it can get frozen. But during summer, obviously, as Dr. Alex mentioned, climate is similar to Serbia. During summer, this is a river where you can see many boats and people sitting, and the restaurants here, so people are having a good time. Now, it has happened in the past that harmful algal blooms have spread, basically from Lake Erie to Mami River. So Mami River, downtown Toledo is around, I would say, 5-6 miles away from Lake Erie. And you see, there are many big buildings, and there are many businesses, and also there's a science museum for kids nearby. And there is a Mud Hens Stadium. So Mud Hens is a semi-professional baseball club, and also ice hockey arena in downtown Toledo. So there's much of human activities that have influenced appearance of harmful algal blooms, with major one being basically nutrients coming from agricultural fields. So if you would go a few miles away from downtown Toledo, you would see many cornfields and soybean fields. And many of those fertilizers actually get washed from the fields into the Lake Erie, so they bring enough nutrients to cyanobacteria living in Lake Erie. Lake Erie is also quite shallow lake, so it's the warmest of all Great Lakes. So obviously high temperature or relatively warm water helps cyanobacteria overgrowth. And the last very important factor is that of these cyanobacteria are photosynthetic organisms, so they produce, they grow up, based on, sunlight, they use sunlight obviously for photosynthesis. So all these three factors, nutrients, relatively high temperature water, and sunlight, contribute to those harmful algal blooms. So I will end up with basically showing what I'm going to present on November 17th. So this would be a lecture related to water sustainability. So we're gonna focus on the impact of energy and other factors on the quality of water. I'll discuss about cyanobacterial blooms that happen in Lake Erie and also toxins found. So I told you major toxins are microcystins, but there are some others, as one of my students mentioned. So those cyanotoxins we analyze mostly by a technique called liquid chromatography mass spectrometry, but we also use some optical detectors such as the UV-Vis detector. And we're gonna mention some of the cases that happened in Ohio, but also some that happened in Serbia. Also talk about some efforts to improve water sustainability, and discuss about the effect of burning coal. Okay, so most of the time we don't think about coal being used in other parts of the world. So coal is not used only in Serbia, but also in the US and many other countries to produce electricity. And obviously it influences the environment and water. So this is my last slide. I would like, since we have, approximately 13 minutes time, I would like to open floor for discussions. I will stop sharing and I will basically, I will ask you,
Thank you,
if
Dragan.
you have, so any questions about those slides that Ivana and Randy and I presented? Well, since there are no questions, and don't be shy, I wouldn't like
I mean,
all of us.
you can ask whatever you like. I mean,
Yeah,
it doesn't have to be too much smart or.
yeah. So every question is good. Since there are no
There
questions,
must be some questions.
Yeah, I would like to ask one question that is related to environmental pollution in Belgrade. Like I read in the news that Belgrade is one of the most contaminated cities, these days. So most polluted cities these days. Is it really that bad? And even I mentioned about some efforts to improve use of solar energy. So any new initiatives that any of you can share with us?
You asking me or?
Anybody who wants? Yeah, you could respond if you want. I think you're inside now, but I often see in the news that like air is polluted and.
Yes, I see that also. I mean, so according to the statistics, it is. So that's why we need something more clean than it's coal and everything else. So, but I guess that part of the pollution it's also because of the digging the lithium at the south of the country and that kind of performance opening, the quite bad industry, and it's certainly related to the bad.
Ivana, is Serbia a major supplier of lithium?
No, basically it's not. I think there is also another country which they have lithium, but it's a quite dirty technology. So, and
Serbia is probably not a major supplier of lithium, but I see that at least some politicians and economists would like Serbia to become one of the major suppliers. They say lithium is very abundant. Now, I also, obviously this is what I read in the news, I also see some chemists, objecting to this and also using, I would say some rationale that is logical, that yes, you could produce lithium, which is very important to produce lithium-ion batteries, but there would be much of pollution of the environment, and there would be, somebody was mentioning about ton of sulfuric acid used in the process, so it would contaminate water immensely.
Yeah, and water and environment, and the company working is quite famous to, to have a quite bad history, can I said, of very bad pollution in other country, which they are, digging and use this lithium. But maybe someone else knows more about this.
I would like to add about pollution in Belgrade, because it's not just the power plants or factories in Belgrade per se, because we have two more problems. First one is actually very old cars. It's Euro 3, I think, cars. And the second thing is actually bad heating system, because you don't have only one. It's not power plant. Well, it's a place where you're getting heating up to old town, where you can control the emissions. Heating plants, okay, where you can control CO2, where you can control something, but for now you have small houses, small households that are heating themselves personally. So that is something second most dangerous thing that provides pollution in Belgrade more than usual. And in these cold days, that is the problem also.
That's an important point, and I've seen that also in the news that there are some incentives, like tax credits that are, used to kind of reimburse people for making better installation in their homes, and similar programs are available in the States, like you could have, some tax credit, if you insulate your home. So I think more should be done in this area. I agree with you, Katarina. Good point.
Katarina, are you talking about, there's something that we would maybe call a central heating plant where some kind of fuel is used to heat water, and that water is sent through pipes throughout a part of the city to provide heat during the winter? Is that the kind of heating plant?
Yes. But that kind of heating plant is not provided for whole city, because Belgrade is much larger than plant, actually.
Right. What is the fuel? Is it coal?
I'm afraid yes. Coal is the main fuel, and when right now the quality of coal is bad, not really usable as much as it should be.
So
do you see emissions, gaseous emissions from that plant? Do you happen to know whether or not they publish public information about the pollution that's emitted?
I'm really sorry. I really don't know about those exactly heating plants, but I know for power plant in where I work, we have to have public information about emissions, and we need to inform local politicians, local custodies, about bigger pollution than usual if it's happening, or about the situation when filtrates systems for filtrating SO2 emissions and CO2 emissions when they are not working or working with low capacity. That's everything we need to inform about. But not only the power plants are the problem. You have one house that it's using coal also, and the other where the guy is not using only coal, but it's burning I don't know tires, really tires, and you have pollution in that from that angle also. That is
but that cannot be the reason for such a high pollution. So there can be only coal or lithium or that kind of really serious stuff. So because when you are talking about the heating, then you are talking about the heating of the quite smaller number of the people, in some area. I mean, concerning that, for instance, in Belgrade, you don't have really any kind of heavy industry.
Yeah, like major
They can cook
fuel.
something like
Coal appears to be a major fuel, and certainly is the major factor for one of the major factors for pollution.
I think.
But I like your points, Katarina, about issues with home heating, and I think one of the goal of this project is also to look at some other communities in Serbia that are economically underdeveloped.
Excuse me for
So
interrupting you. I think in the circle of 100 kilometers around Belgrade, there are two biggest Serbian thermal power plants, Kostolac and Nikola Tesla, and they're using coal, and everything is on the rivers, of course, Sava and Danube for cooling. So
Precisely.
wind blows over the rivers and brings it to Belgrade. So I think that's the major thing, and also Bor and Majdanpek coals mining.
Yeah.
For the pollution of Belgrade. Thank you.
Yeah, that's a good point.
Yeah.
Yeah, like as I mentioned, one of our goals is to look at some smaller communities in Serbia as well. So I know Nikola comes from Zlatibor Mountain, and my hometown is at Kopaonik Mountain. So we likely have a chance to discuss more about issues that smaller communities face, and just to remind my hometown, which is Brus in Serbia. Most people use actually wood, to heat their homes, and this is obviously not the best solution in terms of pollution. So we certainly, as we talk about water stability and solar energy, we're going to talk more about issues that Serbia faces, but also issues that America faces. As I said, Monroe, Michigan has, they make energy in their plant, their power plant from coal, and then when you drive on highway, you smell all sulfur and other type of molecules, coming from coal. So not pleasant situation. And so the same thing is with refineries. They're big, they're polluting the environment and water as well. Okay, we're at 1:29. I suggest we wrap it up unless there is some precious comment from anybody. I think the important thing is that next time we're going to inform you. So next lecture should be in 2 weeks. And I think, Randy, I just saw an email coming from you about setting this lecture. So
yeah, because Randy's first. Yeah.
Yeah, we're going to make sure to inform all participants timely, so that all of you can attend and plan ahead, obviously.
Yeah, so I guess one of us will send a reminder a couple days ahead, but you can already, I think, add it to your calendar, hopefully. And in the meantime, hopefully you can come up with some questions about how that can help us make this project more effective and help you learn more about this. And we look forward to reconvening in 2 weeks.
Sounds great. Well, I'll stop recording and we'll also inform you where you could see the recording of today's lecture. You guys in Serbia have a good night, you know, and thank you
Yep.
again
Yeah,
for joining
thank
this.
you. Please
Thank you,
enjoy the
bye.
class.
Thank you. Hvala.
It's
Thank
really
you.
Thank you all. Bye-bye.
Bye bye.
okay. Bye bye.